Okay, up next we have Bernát Gábor with How We Standardize Editable Installs, PEP-660 versus PEP-662.
Thank you all. Let me start with saying that I appreciate your presence here. I know that this is not a light topic for anyone. As Peter put it this morning, this is probably the place where everyone gets upset eventually. So I'm here today to hopefully help you a bit with that. My goal here is today for you to actually have a better insight on how some of the packaging works. And hopefully, if you run in some of those annoyances, you understand enough of how the system works that you can figure out what's the problem and hopefully fix it with less annoyance at the end of the day. Let me start with introducing myself. So who am I? I'm a software engineer at Bloomberg. I work in a team that primarily focuses on quality control inside data ingestion pipelines. But more importantly for this talk, I'm an open source contributor. Primarily, I'm a member of the Python Packaging Authority, and I maintain the virtual and build PEPs and TOCs projects, which are the more popular ones. And also, I'm the parent of 2 Yorkshire Terriers, and I'll employ their presence, at least in the site virtually, to hopefully give you a bit of relief for the dense subject of packaging. Okay? Now, let's start with what is editable installation. But before we can actually understand how we standardize editable installations, we have to understand how things worked in the past, then where we ended up today, only then to realize what we propose and where the future is heading. I hope you're all eager to find out more about how editable installs works in the past. And for that, we first need a very quick demo project. Here is a quick demo project for your amusement. You can see it's very simple, doesn't do very much. It literally just has a simple say hi method or function, and you can call that function and call it, you're going to say, hey, it works or not. Now, if you just create this source directory and start up your Python interpreter and pass in your testing code, basically calling the method, you'll see that it's not working. And the reason for that it's not working is to actually test the library, you first need to install it. So let's do that quickly. Hopefully you're using virtual environment for this and not installing in your global Python interpreter, because that's the surest way to eventually have a bad day. And as we know, packaging is already a bad experience. You want to avoid getting there quicker. Now, so usually what you're going to do it, if you have a virtual environment, you're going to use pip to actually install your package into it. And I know the might not be I'm not sure how much they show up, especially in the back. But in the first slide, there was a link to it, so you can check it out later, whatnot. I'm going to highlight the parts that are more important. Here, basically, the only thing you really need to know that I installed the project. After I installed the project, now if I run the interpreter again with my test code, you can see that, hey, it's worked. Now I can test my code greatly. But you can see I kind of made a bit of a mistake here, because I said hello, and I actually didn't put an exclamation mark. And if you're one of these grammar Nazis, you're probably screaming at me already. So let me fix that quickly. I'm going to quickly put an exclamation mark in it. I run again my test code, and nothing changes. It's the same thing. And you might be aware of the reason for this is that whenever you change a code to actually test your library, you have to install it again, and only then you're going to see that, hey, now you have the new change. Obviously, reinstalling your project after every change is not a good day for anyone. So there must be a better solution than basically, whenever you change the code, install the project again. And the solution that we're looking for is editable installations. Editable installations are basically a way of installation which allow you to install your project, which allow you to test your project without needing to reinstall your project between code changes. Now, you still need to restart your interpreter to pick up code changes. However, importantly, you don't have to reinstall it. Now, the way this historically used to go, it was pip exposed as an editable installation mode, and it was exposed during this -e flag. So if you pass to pip this -e flag, it's going to do a special type of installation in which once you run it, you don't have to reinstall it after every code change. It automatically picks up the new information that you put into your business. Now, let's dive deeper. Let's check out how actually those editable installation works in the past, what happened a year ago, or potentially even today if you're using setup tools, when you actually type -e to pip. And what happens is basically it inherits a solution that was introduced back in like 2003 or whatnot by these two tools and then inherited by setup tools. And the solution is essentially calling the Python setup.py develop command that magically makes your project source directory be present inside the Python interpreter's import resolution system. Let's check out what it means to install your project. Let's find out how a normal installation works so we can kind of like identify what are the differences from an editable installation point of view. And the way a normal installation works is that pip will take a look at your source directory, will build a wheel from it, and then it will install that wheel into your side packages in your Python interpreter. Now, when it builds this wheel have two kind of information in it. It will have your actual business logic. For example, here you can see like the demo init.py is your business logic. And then it's going to also generate some kind of package metadata. And this is basically information that before building your wheel was stored inside like your pyproject.toml or something like that. Now, if you look further, the next step, as I said, after it creates a wheel, it will actually extract that wheel into your Python interpreter. And that extraction basically means that it's going to take your wheel and extract the content of the wheel first inside the Python side packages folder, and also generates the binary compilations for those files that it extracted for the Python files, but also enrich a bit the metadata that was available in the wheel, basically just provide additional information that's useful for the installer, in this case pip, to find out how it can uninstall the project and all that kind of stuff. Or even just, for example, the installer is there just to point out that if you have another installer than pip can kind of like get to know, hey, I shouldn't touch this because it's not my package, I don't know how to handle it. Now, the difference whenever we're calling about editable installation is that what actually happened in the past, as you can see here basically on the highlighted, on the output of the pip install, it doesn't do any of this wheel building magic, whatnot. It just runs setup.py develop onto your project source directory, and then that invocation somehow makes the magic happen. And when I say it makes the magic happen, so what the magic is actually, it generates your project metadata inline inside your source directory. So that's why if you install a project in editable install, or you used to install it, there was this magical aginfo folder in your folder, because it still needs the project metadata, and this project metadata now is stored within your project source directory. And then it uses a system called pth files, and it adds this pth file your side packages. And what you need to know about the pth files, that whenever you add a pth file to your side packages folder, that basically just gets picked up at the interpreter startup and gets added to the sys.pet. If it's a pet, if it's Python code in it, it will actually run the Python code. So for example, in this case, you can see once I run setup.py-develop, it generates that aginfo folder, but also takes the source, my project source directory, and injects it via the pth file onto the sys.pet. Then from there, the Python import system takes it away and makes things work. So you can see this was the old solution, and you might ask, why isn't this enough? Isn't this all we need? Do we need anything more complicated? Like, maybe you already solved this problem. And I'm here to tell you that, no, this is actually not the full solution. This is a partial solution to the editable installation problem. One of the problems is that it still requires the setup.py file, and the setup.py file is basically some setup tools / these two tools are correcting. And for example, we have a lot of fancy new backends like Fleet, Poetry, or Hatchling, and all these still need to generate the setup.py if they want to develop an editable installation mode, which is not a good, so we should have a better solution. Also, another problem is that, and this kind of like iterates back what actually we want to solve here, we as a community never really got together and agreed what is an editable installation, other than the broad definition I gave it earlier on. Or like, where are the boundaries for what an installation should be able to do and shouldn't be able to do. And also, furthermore, as I said, this thing that I presented until now is basically an implementation detail of setup tools from the earlier ages. You might ask, hey, Bernát, it's 2022. Why is it still a problem? I mean, Python's around for 30 years. I thought we should have solved this 15 years ago. And I'm here to tell you that it's not that because we did not try. Oh boy, no. We did try more than once. It first initially came back when we started to standardize the normal installations in 2015. And it was so controversial back then at that point that the writers of the PEP-517 explicitly stated that someone else, someone later, going to solve it. We don't want to deal with this because otherwise we'll never get anything accepted. Then it came 2019. We tried again, part of the packaging summit at the previous in-person conference. We even agreed on a solution, and we all walked away that, hey, just we need to implement it, ship it. Then after the conference, there was more follow-up discussion. Not many concerns were raised. Until 2020 April, when someone opened again the topic that, hey, we agreed that we're going to do it, but we didn't do actually anything. Like, can we start the work on it? So that generated a whole new work, only to prove that actually whatever we agreed at the packaging summit, we didn't agree. Like, many people had concerns to it. So fast forward another year, so this is like the 5th try when we go at it. Someone again picked up like, okay, can we actually solve this? And we then again and then we even had 2 main threads. Each of these threads, I warn you, are probably like 500 comments each thread, basically discussing various back and forths on the subject. And I'm happy to say that after that 2021 April-May edition, we actually did agree, mostly, but not really. I'll let you know later on that. But first, in order to actually understand why we had so many back and forths, I need to tell you about what were the drawbacks of the prior art, basically what were the problems that the previous solution did not actually handle, and many people felt that we should handle as a language. One of the problems that the previous solution didn't handle is that imagine you have a project and you want to basically include some files in your project. And for example, setup tools have this packages thing where you can specify one by one what package you want to include. Now, in case of an editable install, once you did this exposed every package. Even if you choose some of the packages to not include, the editable install still installed all your packages or made it available, all your packages in your editable installation, basically driving a divide how an editable installation and normal installation was working. Also, the reverse is true. If you wanted, for example, to exclude your test files in an editable installation, it wasn't possible. If you put it within your project source directory, it automatically picked up, because the previous solution basically relied on the fact that we put your source directory and put it as it is as a whole onto the side packages folder. So there's no let me add this or let me not add this type of exclusion logic possible to happen there. Another problem that we don't have a natural solution is, like, for example, generated code. Imagine you have some kind of schema file, like a schema file in which your services API is defined, and you want to generate some Python classes, for example, using PyDenting classes by using this data model code generator. You can set up a build where you generate this file during the build of your package, but this will not be run during your editable installation, and it's not clearly defined how it should this even for an editable installation, basically including generated code as part of the editable installation, not just static code that lives on your disk. And also another problem is editable installation work as previously were defined mostly for Python file, pure Python file. But for example, in an ideal world, it should be possible to also work for like C extension. For example, if you have a Python package, it should be possible to, whenever you update your Python code, you don't have to like rerun again the entire installation just to pick up that Python code change. Ideally, it should that also translate automatically. Again, for this, we don't have any support. The way historically it worked, that during the installation, these extensions were injected into your project source directory, and it was up to your responsibility whenever you do change the C extensions, just reinstall the package to pick up the changes. But then we brainstormed throughout all those back and forth sessions that can we even solve some of this problem, or are they even worth solving? And we did come up with a few new solutions, or also have some of the system try to solve it. Basically, how can we have a life without the PTH files that we had, something that's more powerful? One obvious solution, or someone came up, why wouldn't we, instead of just using PTH file to kind of like inject the source directory inside the side packages, why don't we use symlinks to basically take the source directory and symlink it into the side packages? And this also has the advantages that now from the port of the interpreter, that files actually physically live inside your side packages rather than kind of like living it inside your source directory, and you can have like path differences between the installation and the editable installation. Now, this also has some benefits, like there are no startup performance impact. You can also basically mirror the normal installation mode. There is one downside. If you symlink your entire folder, remember from the previous bullet list where I said that we wanted to support addition, exclusion, code generation, and let's say C extensions. This solves you the addition problem, but doesn't solve you the extension, because once you symlink a folder, everything in that folder is available. So it's not the full solution, but potentially can be better than the PTH file. You can also choose to symlink the file individually. This has the advantage that now you can support exclusion, but that does mean that whenever you add new files to your project, you need to rerun the installation to update the symlinks basically to your side packages. So this is also not necessarily a perfect solution, but sometimes can be better than the normal PTH file. Another great solution or great improvement that has been added through the last 15 years to the language are import hooks. The import hooks that we were working, at the end of the day, if you think about it, in Python, we import modules, not files. Let's use that. Like, why do we even try to solve the file problem if at the end of the day what we want to solve is the fact that an installation load the correct module rather than we don't really care where that file lives. And we could, for example, with this thought, we can extend the import system to manifest the module at import time and manifest it from the correct location, wherever it lives. If it lives inside the side packages, cool. If it lives in your code, cool. Or if it lives maybe in memory, because it's generated, cool, it can manifest it from there and doesn't have to actually exist on the disk. It basically offers the full dynamic thing. We brainstormed, I myself with Paul Moore brainstormed on this in 2020, and he even made a library that basically allows any backend to kind of like provide this kind of functionality. Okay, and the way it works, it still uses some import hooks because it still needs to have some kind of system to register the import hook at the start of the importer. So some code needs to run at the interpreter startup time, but that does a lot less because now just registers the import hook, and then dynamically at import time, it kind of like can support both exclusion code generation, or for example, here you can see what we actually do. We map our demo module to a given init.file, and then the import system will take care of to load it from the correct location. Yeah, so this is mostly a great solution, solves all our problems. I hope I didn't put you to sleep, though. And let's have a look first now at the Python build system. So in order to understand the solution we propose, there's one more thing that you have to know about, and that's the Python build system. In order to build the wheel, what actually happens to build the wheel? And two distinct components need to work together. First, the build backend. This is like setup tools, hatchling, fleet, whatever else you have, which basically actually builds the wheel. And there's the build front end, which creates an isolated build environment for your build backend in which it can run, basically something that makes sure that you have the correct version of the setup tools, all that kind of stuff. And this also installs additional dependencies needed. That is really small, the text there. But yeah, and then we can call the build backend. The build front end is the one that actually communicates with the backend to the API defined in PEP-517. And the two main important methods, kind of like it's the Python API, are the get project for build wheel, which basically give me what additional dependencies you need to actually build the wheel. And the other one, actually build the wheel. So these are the two main Python interfaces that need to exist in order to build the wheel. You can actually see this if you use the canonical project, pyproject.build, to build your project. For example, here I demonstrated the virtual env. You can see when I said, hey, build me a wheel of this, the first thing that happens is create a virtual environment. Then it's going to actually install in that environment your project's build backend, in this case, like setup tools and setup tools SCM. And then it asks the backend, hey, what other dependencies do you need? And the backend comes back, I need the wheel. So the front end will now install that dependency inside your isolated build environment. And then it just calls that build wheel method, which actually builds the wheel. And you can see at the end of it, you end up with a wheel. Okay, so these are kind of like the main steps how a wheel gets built. And with that, now we know enough to actually solve the problem, yeah? And this is the point where I have to say that after 12 years of arguing back and forth on how we should solve the problem, we actually managed to not agree on how to solve the problem. So we had two solutions. So we decided to propose both solutions and pick the winner, basically, at the end of the day. Now, the reason for this one that we kind of like, as a community, failed to agree who should actually do the most of the heavy grunt work. Should it be the build backend or the build front end? Who should actually be responsible of making the editable effect happen or work? And we have a PEP for each of them. We have the traditional wheel-based, and we have for the virtual wheel-based, which is one of them puts them in the build front end, and one of these the build back end. Now, at this point, I should probably address that generally the way the Python enhancement works is that people propose a solution, and that the solution gets debated, and the solution should be something that the community agreed on. Now, obviously, we're not always going to agree on, and that's fine. Sometimes we can agree to disagree. Also, it's not necessarily a bad thing that we as a community could not agree in a single solution, because if we have two solutions, we can kind of like compare them against each other and make the least solution, because it's not always possible to find a solution that fixes all your problems at everyone's problem. And oftentimes, it's even more important to pick a solution rather than, instead of being afraid of picking the wrong solution, do not pick either solution just because as a community we could not agree. But with that being said, let me tell you a bit about the first installation. So the first installation mode that we came up is the PEP-517. And for those of you wondering, yeah, this is the one that actually got accepted. So the way this works, this puts most of the heavy lifting onto the build backend. And it adds two methods to the communication channel between the build backend and the front end. It defines this that now the editable installations also have their own isolated build environments. And this editable build environment can have additional dependencies. For example, if you want to build an editable wheel or a normal wheel, you may be able to specify different dependencies in order to actually build those wheels. So that's why we have another endpoint that basically provides, hey, backend, get me the requirement for your building an editable wheel. And then we have a build editable method that actually, hey, backend, provide that wheel that you build. And the editable installation, this is basically all this actual PEP actually contains, because now from this on, it's defined the editable installation works by first the build front end will create a custom isolated build environment. It will install into that isolated build environment your project's build backend. After the build backend, it asks the front end asks the backend, hey, what are additional dependencies needed to build an editable installation? And after the editable installation, it installs that. It basically just asks the backend, build me the editable install. And the entire installation from this on and on installation works the same way it works for the normal wheels. So there's no change needed on the installer side or anything of that. It basically delegates all the responsibility on the backend, and the backend should generate appropriate files inside your wheel that makes the editable effect happen. Okay? Now, this has some benefits, like for example, the backend can choose to put an import hook there instead of actually putting your source files. It can put a PTH file, so basically whatever was working until now can continue working. And also the backend, whenever about making which one should you actually use, the PEP kind of like says that, well, the backend should probably allow the user to choose whichever they want. And yeah. Now, there's one solution out of the previous kind of like semi-solutions I presented that this doesn't support. You can see that we propose that you could use symlinks to achieve the editable check. Symlinks is not achievable today because the wheel standard doesn't support symlinks. Like, there's no point to define it. And the kind of like the conclusion was that if anyone wants symlinks in their editable installations, they should propose an additional PEP that extends the current PEP standard to support symlinks. And the big benefit of this, as I said before, and for the installers or non-installers, there's no change. They use the existing mechanism. Now, here's 662, and this is the PEP that actually I wrote and proposed. So this was like my solution, even if it wasn't accepted. The idea with this one is that instead of making all this work be handled by the backend, why doesn't the backend just provide some kind of metadata file, like a JSON file, which just basically lists what modules need to be pulled from what files. And then the front end is the one that actually needs to make it happen somehow. Now, and the front end can, from there on, decide to use symlinks, PTH files, cycustoms, import hooks, all that kind of stuff. This has potentially the benefit that it doesn't require extending existing standards, because the front end is not bound by the existing front ends. So it can choose, for example, to use symlinks, or it can choose to use customized files, any of that. Now, ultimately, choosing a winner, the decision was primarily made by Paul Moore, who's kind of like our BDFL for packaging. And after a week, when none of the proposals received any significant feedback, he made the decision that he picked the PEP-6060 as the winner, and this happened last year in June. And his primary reason why he preferred the 660 over the 662 is that he felt that the PEP-6060, by just basically imposing on the backend to enlist what type of files needs to be, or modules need to be exposed and from which locations, it's a bit too vague, and it doesn't really specify for the front end what it needs to do. And he did not really like that kind of like full control on the front-end side. While if you consider the PEP-6060, that is much more constrained because both the backend and the front-end knows exactly what files they need to produce, even though the backend still needs to solve all the problems, how actually make the editable installation effect happen. Okay. So some lessons we learned. After adopting the new standard, a lot of the backends happily jumped on. From that line, it was a resounding success, I suppose. For example, Hatchling, PDM, ISCONS, Fleet, Poetry, within a few months implemented the standard, and now you can use editable installs without setup the Py for these projects. You may notice one significant omission from here, and that's setup tools. So basically, the one that 90% of us use doesn't actually. And the problem here is a bit difficult. Like setup tools doesn't necessarily want to take PTH file and just add support for a PTH file, basically a direct migration. They would like to improve the existing system, but improving the existing system and kind of like adding support for like more smart editable installation, it's hard because setup tools is very much pulled down a lot of technical debt, a code base that basically goes back 25 years, and adding changes like collecting all the files that are actually going to be installed or modules that are going to be installed, it's a hard problem within the system of that project because of its architecture. So not all great, and what's not, there's one more black swan we did not see coming. And this was kind of like, some of these projects I started using it, and this also proves that even with 10 years of disagreement, we still can miss things. It turned out that we missed with the import hook solution that import hooks are great because they allow you to solve all the problems, and they allow you to dynamically make any kind of logic happen. The problem is they're really bad for any IDE or static checkers, because any IDE or static checker doesn't execute any Python code. So if they don't execute the Python code, they don't know what type of import hooks do, what kind of modules they make happen. And I'm not even sure that this is an easy problem to solve, because if you think about it, if you go from a concern that you never can execute any Python code, anything other than explicitly stating what additional files you want to expose inside the Python interpreter will not work. And this can like suggest that the proposal that the PEP-6062 was, that basically proposed exactly this, to provide a file to the front end that can basically list, hey, these are additional files that I want you to make available. Now, this kind of like points that maybe we will not have PEP-6062, but if we want users to actually use our editable installations, because not having autocomplete on your IDE is going to be a major pain point, we will actually need to extend PEP-60 to still require the backend to generate these additional files so that the static checkers and the IDEs can actually know about them and index them as they did beforehand. In the meantime, we can still using the PTH file, but that's kind of like, we did not really solve much, but made maybe available some of the things to the people. To the newer backend, made them work without needing to generate this custom setup.py file. Yeah, that's mostly it. I'm not going to take questions right here, but if you have any questions, find me after the conference or right here and right now, and I'm happy to answer any of your questions. And with that, I would like to thank you very much